our speaker today is Dr. Thomas A. Searles, who's going to talk with us about quantum research at HBCUs. Dr. Searles currently serves as the associate professor in the electrical and computer engineering at the University of Illinois, Chicago. This past year, in 2020, 2021, I guess a few years ago, he was the MLK visiting professor at MIT, and he also served as a director of the IBM HBCU Quantum Center. Dr. Searles received his PhD in applied mathematics from Rice, where his thesis work primarily focused on magneto-optical properties of carbon nanotubes. He was also recently at Howard University, where we overlapped as faculty. And so while he was at Howard, I guess I was there too, Dr. Searles established a new research program in applied and materials physics, which now focuses on quantum materials, metamaterials, and quantum information science and engineering. In recognition for his research in light matter interactions and his capability to train and mentor Black students and all students of physics and engineering, Dr. Searles was recently awarded the inaugural AIP and SBP Joseph A. Johnson Award for Excellence, and he's also a recipient of the NSF Career Award. Dr. Searles is a proud graduate of Morehouse College, and where he majored in mathematics and physics. He's a native of Albany, Georgia. And with that, Dr. Searles, we welcome you back to the great state of Georgia and also the Atlanta University Center. Welcome home, and look forward to hearing your presentation on quantum research at HBCUs. Dr. Searles?
Awesome. So thank you so much, Dr. Washington, for that kind introduction. And I'll load my slides now, get us started. Let's see here. Okay, awesome. All right. So one of the things that I'd like to say is thanks to the organizers, Dr. Washington and the AUC Data Science Initiative for this gracious invitation. I've always looked at kind of what Dr. Washington's done with the Data Science Initiative as kind of a model for what HBCUs can do with respect to building large center efforts across many campuses for an emerging technology. So whenever Talitha asked me to do something, I definitely do that. And then just for everyone's efficacy in the audience, when either Spellman sister Talithia or Talitha tell you to do something, you just say yes and say, how can I do it to the best of my ability? And on that note, one of the things that this Dr. Washington told me to do was to talk about quantum research at HBCUs. However, I'd like to currently point out that I'm actually at another MSI and HSI that's not an HBCU. So that's why that asterisk is there. Typically, I leave my email address on these types of things. It's just tsearles@uic.edu. But I'm more than happy if you all can, I'll type it in the chat or something like that, but more than happy for people to reach out if they need anything. So that said, you know, I'm now outside of the HBCU space, even though the majority of my career was at an HBCU. However, this won't be the first quantum talk by some visitor to come to HBCUs. So here's what you see is a historic photo of our one of the esteemed colleagues in physics, Albert Einstein, which you all can recognize. And at this time, I mean, he was in New York Times. He was essentially a celebrity. And everyone and their mom was trying to get him to come give a lecture at their university. And Einstein, as a member of the Black community, actually in Princeton at the time, really felt that the best use of his busy schedule was to come give this talk before the commencement at Lincoln University to some HBCU students that were interested in the latest and greatest physics. So I'll try my best to impersonate Einstein today by giving you all a little bit of quantum, but also kind of letting you know how happy I am to be at this venue to speak with each of you. So just a little bit, and keep this in mind. So I understand that we have a lot of different backgrounds in the audience, and I just want to all start at the same point. But you may or may not have heard from Marvel movies or other things about this idea of quantum. And in particular, the way that we'll define quantum is really basically anything that can be described by some Hamiltonian that gives a quantum advantage in some way versus classical physics. What I mean by classical physics is the physics that we experience in the world today. So we're studying energy, that's work energy, force, physics one, physics two. You can apply those same equations to electricity and magnetism. And then you can do that to some extent throughout the study of light. And then here just gives you this idea of kind of where quantum starts. So this is the break from classical physics. And when you take your modern physics class, this is or your quantum mechanics class, you're mostly up in this top part where you're talking about the quantum postulates. You may talk a little bit about black body radiation, photoelectric effect, which was founded by Einstein, wave functions, and that type of thing. So we in physics, we call that quantum 1.0. And Quantum 1.0 actually had a lot of useful technologies that are ubiquitous today. So this idea of quantum is not new. There's lasers, there's light emitting diodes, there's any type of solid state physics, superconducting magnets, magnetic resonance imaging or MRIs, your CCDs, atomic clocks. All of these things are current technologies that are based on what we're calling quantum 1.0. So today, when I talk about quantum, is actually after the quantum initiative that I'll present, and really, particularly in this graph, we're talking about quantum information. So this is this idea of qubits and using qubits that are entangled or having some type of qubit coherence or phase or time synchronization between these two objects. So anything like that, then we're starting to think of quantum communications, the quantum internet, quantum computing, and quantum sensing. So in today's context, unless it's otherwise stated, I'm talking about quantum information science and engineering. Oh yeah. So that said, just a little bit, it is Black History Month. And this is the topic of quantum research at HBCUs. And one of the things that you'll notice is right in this top corner, there's something called the atomic spectra. It's typically presented in modern physics for those that have a physics curriculum. But sometimes it's also presented in chemistry class. That's where most of our quantum is introduced at a high school level. But that said, one of the experts in atomic spectra was actually the second Black person in the US to earn a PhD. This is Dr. Elmore Ines or Professor Elmore Ines. He got his PhD in 1918. And he was a faculty for some time at Fisk University, which is an HBCU in Nashville. They now have a storied program with Vanderbilt, such that creates many, many physicists. A lot of my colleagues have graduated from Fisk University. But an interesting note that I found looking Dr. Imes up is that he actually had his first teaching experience at another HBCU, this Georgia Normal Institute, which has now grown into the Albany State University, a place that, again, I grew up in Albany and took classes there, and my parents and others in my family and friends graduated from Albany State. So that said, he has this expertise in atomic spectroscopy. There he is in the laboratory. Note that that Physics Today article is written by Dr. Mickens, who had a storied career at Clark Atlanta University, and we'll actually highlight him a little bit later. But last but not least, something that I also want to point out is that Dr. Imes, he advised a woman by the name of Carolyn Parker, who went on to MIT to get her graduate degree in physics, where she was the first Black woman to get any type of postgraduate degree in physics at the time. Unfortunately, she was in the Manhattan Project, and she passed away by doing experiments on radioactive materials. As such, there's a current fellowship that I encourage all the students to take a look at, this Carolyn Parker Fellowship at Fermilab. So if you're interested in that, please let me know. But back to Dr. Imes. So as I said previously, he was an expert in atomic spectroscopy and really measuring out the atomic lines in this case of hydrogen bromide, hydrogen fluoride, hydrogen chloride. And this spectra was published not only in the Astrophysical Journal, but as you'll see, like many Black physicists of its time in quantum, they were also publishing in the Physical Review. If for more information and cool stories about just kind of the state of being hashtag Black in quantum, I encourage you all to take a look at the Symmetry article. So Symmetry is out of the Fermi lab, and it's their magazine with Slack. And there it highlights the important roles in the history of quantum physics. And in particular, it talks a lot about Dr. Imes' career in not only the great things that he's done in science, but himself as a faculty member at Fisk and his impact on the community in the Harlem Renaissance. So I encourage you all to take a look at that. Last but not least, I'm sorry, the next person that I'd like to highlight is Dr. Warren Henry. So Dr. Warren Henry was actually the son of two parents that graduated from Tuskegee University. He got his master's from Atlanta University, which is now Clark Atlanta, and his PhD from UChicago. He has a rich history in magnetism. And one of the things I used to tell the students at Howard, where he was also a professor at some point, was that in one of the largest, or the most widely used physics textbooks, this Holliday, Resnick, and Walker, some of the data that he took while he was a professor at Howard and also working at Naval Research Lab, which you see him there working with a cryostat, was actually in that book, and it's in every edition after that. So it's a little bit of quantum history from HBCUs that's really has a broad impact across the entire physics community. That said, he was widely recognized as a great scientist, a fellow of the American Physical Society, and a Triple S, which is a big deal, something that I aspire to do one day. These are a couple of his papers in Physical Review in the 1950s. These are single author experimental physics papers in the 1950s. So that shows you what type of beast Dr. Henry was. That said, the next physicist that I like to highlight is one of as a Morehouse man, like our GOAT when it comes to all physics things, but especially when it comes to condensed matter physics. But this is Dr. Walter Massey, who was the president of Morehouse College while I was there. This is a young Thomas Searles. And then fast forward, recently I reconnected with Dr. Massey at the Chicago Quantum Summit. I guess I need to get back in the gym or something. But that said, Dr. Massey, he's had a storied career in academics and administration. He's on the board of Bank of America, all types of great things, but he really uses expertise in theoretical condensed matter to achieve all of these things. And another interesting note with respect to quantum is that the first National Society of Black Physics meeting, Dr. Massey gave a talk on quantum spin liquids, and I forgot to get his paper there. One of the things that I also wanted to note too is that there's a photo that's missing, but I'll send it around for everybody. But this is out of the Ebony Magazine's article, which was 1949. So Dr. Massey was actually one of he was the director of the Argonne National Lab, which is one of the Department of Energy labs in Chicago. And in 1949, for those that have seen Oppenheimer, you might have noticed what a large effort it was, a worldwide effort, or really a national effort, which we'll talk a little bit more about getting people involved for building the atomic bomb. And one of the things that they did in Argonne Lab in this Ebony issue, which unfortunately you can't see the cover, but I'll make sure that the copy I send there or everyone has this cover, is that it highlighted 10 Negro scientists at Argonne to help harness atomic energy, and they called them the atom scientists. And then something that for physicists to know is that that's probably one of the last times that there was tens of Black scientists at any energy lab. It's something that through different efforts with the Department of Energy that we're actively working on trying to get those numbers back up. For a little representation and some other things that I like to highlight, for not necessarily done at HBCUs, but Dr. Jackson definitely contributes to many HBCUs through her work now at NSF. But she was the first Black woman to get her PhD in physics from Stanford University. She has expertise in quantum technologies, quantum sensors, quantum optics, and photonics. She worked with John Dowling at the NASA Jet Propulsion Laboratory, and she's currently an NSF program manager for center efforts like the Energy Research Centers. There to the left, you see this NASA Tech Report published with John Dowling that uses correlated photons to suppress background noise. This is really the heart of single photon generation, which is the backbone of the future quantum internet. So that was all developed while at NASA by Dr. Jackson. And it's something, interestingly enough, that my student works on at the Army Research Lab. So I think that's pretty cool. Then another story. So this Dr. Washington can tell some great stories about Dr. Harris here. But Dr. Harris was at Howard University. He actually started straight from his PhD at Cornell, drove down, I think in a Volvo, if I remember correctly, and started his tenure track job at Howard University. And then there he studied the growth of silicon carbide. Silicon carbide is a vital material for many integrated photonics, quantum sensors, quantum communications, NV centers, that type of thing. And Dr. Harris literally wrote the book on it. You can see his book there. He also, again, did great things at Howard University that I personally benefited from when I was there. This is building an HNF, but also having a MRSEC, which is a big deal. And then last but not least, but something that I'll definitely get into is during my time at Howard from around 2013, and it just sunsetted, I think, around 2023. But Dr. Harris was the PI of the Center for Integrated Quantum Materials, where Howard was a partner with Harvard and MIT. And which we'll see a little bit later, this was one of the only large quantum efforts funded by NSF, if not the only. It was the only one when they started the National Quantum Initiative. And that was all done by Dr. Harris while he was at Howard University. Again, I'd like to highlight Dr. Mickens. So can't be at Clark Atlanta and not think about Dr. Mickens. One of the things that I kind of regret was that he was legendary for having lectures in math methods and quantum during my time in the AEC, and I never got a chance to take his course. But he did have expertise in quantum dynamics, and actually one of the colleagues, Dr. Oyedeji at Morehouse College, and Dr. Mickens have some really good papers in the physical review on that topic of quantum dynamics and really quantum materials, things like graphene. One of the other things that I'd like to point out is that really and truthfully, Dr. Mickens has a broad impact of documenting the lives of Black physicists. That's how I learned, other than direct contact of meeting people at NSBP or being cool enough for them to call me on the phone now. That a lot of the things I learned about Black physicists comes from the work that Dr. Mickens published. And a lot of these publications are in the literature, things like the American Journal of Physics, Physics Teacher, and on throughout NSBP. And one of the works that actually referenced, that was referenced by Dr. Mickens was that of Herman Branson, which gets us a little closer to the topic. Oh, no, sorry, it should say Herman Branson there. Sorry for the errors today. As I was telling Dr. Washington, I had to recreate a lot of my slides because I lost my computer in the airport in January. So bear with me. But that said, this is Dr. Herman Branson. He got his PhD with Boris Podolsky. This is of the EPR pairs, or the EPR paradox, which really challenged this idea of non-locality in the strangeness of quantum. So he's got his PhD there at Cincinnati. And then at that time in 1939, he was the fifth Black person to get their PhD from a U.S. institution in physics. He was also storied. I had really great expertise in X-ray crystallography, where he performed research with Linus Pauling on several visiting faculty positions and sabbaticals there. And then I think one of his greatest achievements is, as Dr. Washington could tell you, that he was faculty at Howard University for 27 years. And I think that's just amazing. So that said, while he was there, one of the things that Dr. Mickens pointed out for me was that he wrote this very interesting article in 1942 to the American Journal of Physics called Training the Negro Physicists for the War Effort. So at the time, I was an assistant professor at Howard University. I had just started my career, and it was just telling him how interesting it was in the way that, as the chair of the Howard Physics Department in the 1940s, what many of the challenges, many of the things that, many of really the motivations that Herman Branson had in educating Black students and giving them opportunities in physics, in in mathematics, in these engineering disciplines, what that could do for the nation. And then in this, what he kind of says is it's not really a question of Black colleges getting their fair share of any type of appropriated money. It's really the job of the HBCUs as an American institution to serve American students, which happen to be Black. And I really think that that resonated with me at the time at Howard University, and what you'll see a little bit later motivated me to start the IBM HBCU Quantum Center with Dr. Kayla Lee of IBM. So just a little bit about myself. So I went to Morehouse College, as Dr. Washington stated. I was very, very lucky to be bribed to go to Morehouse at the time by my sister. My middle sister's on the line. My older sister was the one that bribed me to go to Morehouse. But at the time, I didn't realize that it was a place for me to be. For many, many years, I graduated in 2005, so I'm covered in this effort. But from 1999 to 2020, Morehouse has led the pack in graduating students in physics, and it's something that continues to happen now with Dr. Red, who's the dean there, and then also the chair, Dr. Wesley Sims, who both interact with the Quantum Center. But of course, you know, other HBCUs and any of these darker dots shows you kind of the fact that the heavy lifting for physics education at the undergraduate level has always been in HBCUs. To the right, what you see there is my mentor, Dr. Willie Rockford, who's now the chair at Morgan State University, and my PhD advisor, June Kono, who's still at Rice University. And one of the things, or one of the reasons why I like to show this photo is that later in life, as a PI, one of the things that I had to really focus on is how can we create, in particular, more Black women PhDs in engineering specifically. And unfortunately, that literature did not exist. So the only literature that did exist was how can you get a PhD, a young Black man to get a PhD in engineering. And, you know, that was me. So I read the story, and one of the things that is highlighted was that you had to have a great relationship, constant contact, and constant encouragement from your undergraduate advisor. My undergraduate advisor's here in the picture. And then the other thing that they said really contributed to student success for Black male PhDs in engineering was your current PhD advisor's ability to integrate you into the culture of Rice University. So a lot of kudos to this entire graphic, because this entire graphic allows for me to do, I think, a lot for a lot of young people. That said, I fast forward a lot. I was able to go to Howard University. And then at Howard University, after I joined as a tenure track faculty member, I was donated 2 optical tables. This is in the new and it's actually funny, Gary Harris himself, along with a bunch of Howard football players, and maybe I helped a little bit, actually move these optical tables into this lab, with some funding from AFLSR and actually funding from this NSF center that Dr. Harris started. Then I was able to get students, get laboratory equipment in. This is our first laser. Then we're able to publish in PRB. Right now, this is one of my highest publications. It was in 2018 on terahertz metasurfaces. And I think it's up to 180 citations over those amounts of years now. Then fast forward a little bit more, one of my first PhD students is actually a graduate of Morehouse College, and was also mentored by Dr. Rockford. But this is Chan Kiao's paper in Optica, where we have for the first time this flexible terahertz photonic crystal. And then at the end of 2020, then we started to, I was about to go on sabbatical to learn how to grow these really high quality in the fact of really high triple R values and low defects for um, these topological semi-metals. In this case, this is molybdenum ditelluride grown by my student Fiona at MIT. So this brings us to 2020, right? And then at the same time, at 2020, there's also this idea in 2018 or so that I'm hearing in many, many meetings in Washington, D.C. about this idea of the National Quantum Initiative. One of the things that I left out while at Morehouse, I actually was a student of what was called the National Nanotechnology Initiative. And through that process, Dr. Rockford had us in these large center efforts where students were doing summer efforts and these types of things. But in particular, we were trained in the clean room at Georgia Tech. And I still have a buzz card to this day. And that number that I got assigned in the early 2000s is the same number that I use right now. So the next kind of iteration of the National Nanotechnology Initiative is the National Quantum Initiative, where there was $1.2 billion given initially. And this is this idea to bridge the gap in preparation and also participation of the United States scientists in quantum science and technology. There's a lot of political things with respect to global leadership in this space. And importantly, what happened as a result of all of this is that there were 10 new national centers, 5 in the Department of Energy. These are around 25, well, I think these are much larger, but these are hundreds of $millions of centers. I think something like 125 million over 5 years, many, many PIs. And then the NSF centers are, I think, are around $25 million, and there was 5 of them. So this National Quantum Initiative put a bunch of money into this effort, again, focusing on these quantum 2.0 technologies of quantum computing, quantum sensing, and quantum networking. So this graphic here gives you an idea of kind of at the time. So this is around 2020, 2021, right after they announced kind of the first quantum leap challenge institutes. So these are these 5 NSF centers. So there's what you'll see is kind of a few things, right? So the first thing that you'll see is a lot of stuff is happening at the coast, right? And then in Chicago, we're doing quite well in building a large ecosystem with respect to entrepreneurship, education, big companies. Everything's kind of centered in Chicago, right? Not a lot is going on in the South. And in particular, something that you'll notice is that if you look for HBCUs, then you'll only see at this particular time one, and that one was Howard University. So if you remember, I talked about Dr. Harris and him in 2013. So this is the Center for Integrated Quantum Materials. I was getting funded from there. And then now you have this NSF ERC for quantum networks that's still functioning at the University of Arizona. And that involves mainly Dr. Brower Thomas, Tina Brower Thomas. And other than that, you'd be hard pressed to find HBCU on this list, let alone an MSI on this list. So that was kind of the distribution of the $1.2 billion, and it really reflected that. If you go to the Department of Energy, then you see something very similar. Where again, if you scroll and you look and you scroll and you look, what you see is you'll see Howard University. And at that time, Howard University was the only one that was involved in the Brookhaven Center. So this is C2QA. This is the Center for Co-Design of Quantum Advantage. I was a member, and once I left the University of Illinois Chicago, then half of my money went to University of Illinois Chicago, and then the rest was at Howard University there. So I say all that to say that with this $1.2 billion, my group could contribute, my group could do a lot of things. However, if you looked at the larger landscape, and in particular, if you looked at the nation as a whole, there was a lot of places that weren't necessarily engaged and participating in quantum research in the way that you wanted for computing, for networking, and for sensing. So that said, and then also the other thing that I would like to mention is at the same time in 2020, that there was a big, large study with respect to how in all demographics in physics that there was an increase, except for that of Black physics students in undergraduate physics, where you can see these are all these different disciplines. So in computer science, there's a dot-com boom, but then it goes down a little bit. And then even though you have all these, you have an increase in total of all bachelor's degrees given to Black students, what you see in physics is that it either goes negative or it doesn't change at all. Again, I graduated from Morehouse in 2005. This data can go all out, way out here, and it's not there. That really allowed for us as physics community to bring this idea of the Team Up report. If you have not read the Team Up report, I encourage you to do so. It talks about how you can instill senses of belonging, physics identity, do effective mentoring and academic support, financial support, and changing actual structures to address that particular problem, right? So I was actually working with the Team Up team on implementing the Team Up report to many things. And then I had this idea that, there wasn't a lot of participation from HBCUs in quantum computing and quantum research. So that led me to this idea of I'm sorry, skipping through some things, but that led me to this idea of creating the IBM HBC Quantum Center. And in particular, why are other motivators? Well, there's $1.2 billion spent by the US in this space. However, if you look at places like China at the time in 2022, this was 15 billion. I think that number is up to maybe 45 billion now. If you look in Europe, Europe has doubled it. It's just an increasing kind of space race like effort to build quantum information all over the world. And then just to give you an idea of the amount of participation. So just in general, these are kind of it's so important that there's agreed upon key concepts. One is quantum information science. So this is marrying quantum technologies or the principles of quantum mechanics, which is superposition, coherence, and entanglement. And you're measuring that with information science. So then you can build new quantum computers, you can build quantum repeaters, quantum communications systems, and then also have higher sensors. So that said, one of the other things is that we as a community came together and said that we need to build a workforce in this area. So there was no participation from HBCUs. There's this new $30 billion worldwide effort to create quantum computers, and there's a need for us to build a workforce, right? So all those things, again, motivated us to focus on not only quantum engineering research, but also to develop programming for students at HBCUs in this space. This is also an opportunity that we could use to really work on a discipline like physics that is historically terrible with respect to diversity and inclusion. And importantly, not only are we dealing with physics, but I'm currently in the ECE department. Many of you might be in a CS department, and what you know is the same old story, is that it's not a very diverse with respect to any way that you want to cut it, including where people go to school, right? So that said, we can really use this opportunity in quantum engineering and quantum information to do things in a different way. And that's something that we are hoping to do. And again, the quantum effort is real, it's happening, it's now. There's many, many different platforms and many, many different companies that are creating these quantum processors. There's also hardware and component companies that are coming around. Blue Forest makes big cryostats for these efforts. There's just solely publicly traded companies like Rigetti. There's the big boys like IBM and Amazon and Google that are involved. There's many startups like Q-Control. And then there's many, many people that have end users that are companies that you may recognize. And some of these companies may even be involved in the AUC Data Science Center. So if you think something like this is interesting to you, please reach out to us at the IBM HBCU Quantum Center or myself directly, and I can let you know how to get engaged with each of these companies. So just to give you a bit, I've said quantum engineering before, but I just want to define it quickly. So there you have things like computer science, mathematics, physics, and typically before then, if you wanted to do some type of quantum, like a lot of the research that I mentioned before back in the day, you would do these few device experiments. And then you also have these more classical engineering ideas are of design and control, where you have circuits and subsystems and DSP and materials fabrication. So if you marry the quantum sciences with these ideas of the engineering principles of design and optimization, then you have what we're calling quantum engineering. And this graphic comes from a colleague of mine at MIT that also works really well in quantum engineering. And it says it's the bridge connecting science, math, and classical engineering disciplines, and that's how we'll define quantum engineering. And just to show you kind of how it works in the real world, if you look at this National Academy's report on quantum computing, all of the quantum actually happens in a very small processor at the end of this beautiful dilution refrigerator chandelier. And then all of the electrical signals back and forth, readouts, control, they're all done classically, including something like this cloud data center over the cloud. And I say all this to say that if students think that quantum is too far away from what they are experiencing or what they're learning, that's not the case at all. There's opportunities for you all to get involved right now in studying these types of efforts in quantum computing. So a little bit more about that before I close, just kind of what we're doing in our lab. So as Dr. Washington stated previously, that we're looking at the physical properties with applications in optics, energy, communications, and security. We do a lot with quantum computing. We're becoming more and more active in the local effort in Chicago for the quantum internet. And then we're also still have a robust program in quantum materials. These are my fantastic graduate students. All of them are women of color. The majority of them went to HBCUs. So Atia went to Morgan State University, and Ashley in the middle, Ashley Blackwell is a PhD candidate, Jim Fellow, and NSF Fellow that is now almost about to graduate. And she came from Dillard University, and Dominique is from Chicago State University. And then we have Sangeeta, who is here from Mississippi Delta. So great team. And then one of the figures that I left out was actually Sangeeta's figure, where we actually use machine learning methods to inform better priors for Bayesian state quantum tomography. So I can send that paper out to those that are interested. Ashley's paper here, we actually use an inverse design method for developing a grid lens. So this is a graded index terahertz lens that we can manipulate terahertz light to then become a hardware aware quantum algorithm emulator in the terahertz regime. And then last but not least, the other large project that we have that marries kind of QISC with data science is using engineering our own data sets with respect to entanglement and purity of the states, and then taking this distribution of states and mapping it onto different processors, whether this is the IBM or even entangled photon source. And then we're able to get better results, meaning faster, quicker, with higher fidelity with respect to using these data-centric machine learning methods for quantum information science. And that's in machine learning science and technology. More than happy to talk about that with anyone that's interested. Last but not least, and note that all of these studies were begun at Howard University. So that was quantum research at Howard. That's now developed more at HBCUs. This is actually one of the papers with the last director. So Dr. Michaela Mu and her student, Robert Coleman. We've got the cover of the AVS Quantum Science, John Dowling special issue, where we applied strategies of the West African game Makala for optimal control quantum states. So in that, we're working with quantum networking, quantum computing that I showed a little bit earlier. And then this is the quantum photonics project that we had that was in Optics Express with the terahertz grid lens. Um, Last but not least, and then I will be more than happy to take some questions just to show you all a little bit about the IBM HBCU Quantum Center. You can read more about it in this paper here. And then again, it was started with my colleague, Dr. Kayla Lee, with the idea that we wanted to build an open, diverse, and inclusive quantum future for the nation and really the world. And one of the things that you'll notice is that if this darker plot is this is the US, that before I said that the National Quantum Initiative basically focused on the coast and the Midwest, Chicago. And then just by virtue of IBM investing in the IBM HBC Quantum Center, now we have quantum investments in places that didn't previously have quantum at all, primarily the South. And that's just a happenstance of slavery was in the South and HBCUs were mostly formed in the South. However, the great thing about that is that we're able to encourage not only our students and faculty, but also our local communities to learn about quantum information science and technology. This blue spot is actually US Virgin Islands. There is an HBCU with a new physics department there that we work with, and we're excited to have them come along. So once we had this, these are kind of the things that we wanted to do was to provide support for quantum research for students. So we have stipends that are given in cohorts for undergraduates. So if you're very interested in that as an undergrad, please let us know. We also fund graduate students for research in this area, amongst other things. And then we've made a bit of a wave. There's YouTube videos, there's new things that are happening. We also have our regular contributors to the Qiskit blog. So this is the quantum information toolkit that IBM developed. Many of our HBCU students are working within Qiskit to do some things there with IBM quantum computers. And then we always kind of have these three pillars. So these three pillars are based solely on the Team Up report that I talked about earlier. So this is this idea of building community to foster a sense of belonging. We're going to support graduate students for undergraduate and graduate research in quantum information, quantum computing, that type of thing. And then we also want to connect. So one of the ways that we're showing how we connect is actually that during NSBE, which will be at the end of next month in Atlanta, that we're going to have a satellite workshop that will focus just on quantum engineering, but for the NSBE community. So we encourage anyone in the audience that's here to please reach out about that, such that you can partake in that programming that we have from the IBM Center. Then just to show you a little bit more, so we give out faculty awards, there's access to the systems, there's joint collaborations, we have working groups. There's also this quantum information science invited seminar series, which is very similar to what you guys are doing here with me. And then there's also this idea of student engagement, hackathons, and all of that. So again, if you're interested in the IBM HBC Quantum Center, you don't necessarily have to be fully engaged in all of these activities, but just as a part of building the community and bringing kind of quantum science to the Black community as a whole, we just love to interact with you all in any way that we can. Just a little bit about kind of our advisory board. JD Whitfield is my Morehouse brother. He was in class with me at the same time. And then there's also Donnell Walton. He used to be at Howard University. The tables that were donated in my laboratory at Howard were actually from Donnell in the 90s. And then these are some other great esteemed members of our board that help us go bring opportunities to HBC. This just gives you a little bit about the research. So there's machine learning that goes on. There's a little bit of quantum education, fundamental research like quantum chemistry, quantum simulation, quantum networking using IBM systems. And then there's also quantum hardware projects that we fund. Last but not least, and I'll close with this, is that the IBM Center not only had this first initial investment, but we're really in the business of empowering HBCUs to do their own thing. And we're very proud that North Carolina A&T not only is a part of QSTEAM, which is this particular press release. QSTEAM brings quantum education materials, make them available to the entire community with a convergence accelerator. But also, we'd like to point out that North Carolina A&T is a recipient of one of these $5 million expanding QIS awards, and they're now a member. Again, HBCUs are growing in this space, so it just used to be Howard, but now it's actually Howard and North Carolina A&T that are members of the QIS Center, C2QA at Brookhaven. Um, and then just another note, Coppin State has been doing great things. Stephen Providence, I'm on a proposal with him with Fermilab. And then also they're joined the SQMS Center there. So that's another highlight. And then also Norfolk State University, they've now have a CREST Center focused just on quantum science and technology. They also, through the center, have also amassed equipment that go on at Doyle Temple, and others are doing fantastic things at Norfolk State. Last but not least, in the AUC, I would like to brag a little bit. We targeted Spelman College to increase or help increase the number of Black women that are participating in this space. So we have a scholar in residence, Dr. Zai, who's working in quantum optics at Spelman. Within her first year, she's not only on my program, which I'll talk about now, but so through the Department of Energy, I have another consortium that involves Spelman College. So they're a part of that. They're also part of the Fermilab Renew project. We also, in my effort, have Southern University and Morehouse College. Just to give you an example of what we've done with Morehouse. So Dr. Wesley Sims, the chair there, he has an expanding QIS award of $800K with UCLA. The actual student that's there is an NSF fellow. So our first NSF fellowship is now at UCLA as a PhD student there. And last but not least, they're a part of this effort where we're building quantum engineering programs at Morehouse and other things like that. So I think that there's still time for questions. I get really excited about this particular topic, so sorry if I went over time, but more than happy to answer questions now or via email. Thank you.
Thank you, Dr. Searles. I mean, I was just so entrenched with your presentation. So yes, at this time, you can stop sharing your slides. And I think people participate in the poll and it's popping up. And I'm just gonna read off some of the stats from the poll. And so about 34% of our attendees today are currently enrolled students. And we have anywhere from undergraduate, PhD, and about 60% are not currently enrolled. But we are all lifelong learners. And about 37% of the participants today are from Georgia, the great state of Georgia. And 60% are outside of Georgia, with somebody joining internationally. So welcome, everyone. One of the questions on the pop-up poll is, while conventional computers use binary bits, ones and zeros, as the process for calculation, a quantum computer uses what? Is it bytes? Is it gigits? Is it qubits? Is it phantoms? Dr. Searles, would you like to enlighten us?
I muted myself. Sorry about that. But no. It's qubits, and I was very happy to see that people got that answer right.
Fantastic.
So, yeah.
Qubits. Qubit by qubit. All right, fantastic, thanks. And so our last question was, quantum computing was first proposed by physicist Richard Feynman in what year? Was it 1934, 1969, 1982, or 2001?
Oh, yeah. So are you waiting on me to answer the question?
Yeah, did you want?
Oh, yeah. 1982 is great. So as
yeah. So yeah.
Oh, I was going to tell Dr. Washington. So my birthday is on Monday, and I turned 41. So I remember when it was the 40th anniversary because it was 1982, and I was born in 83. So that's one small story of why I get to remember why it was made. But it's actually a really good paper. You should read it. I encourage you all to read it. Yeah.
That's awesome. That's awesome. Yeah, but it's like just so yesterday, because you're still like 20 something. So if you could not share, stop sharing your screen.
Oh, yeah.
And we'll just go over some questions here. This was a phenomenal, very interesting. Quantum is a national interest right now. I put some links in the chat so everybody can read on the CHIPS and Science Act and all that other good jazz. So somebody asked what HBCUs are offering equivalency undergraduate and graduate programs.
Yeah, so great question. And it's something that I just like to point out is that many institutions, not just HBCUs, are learning what to do with respect to building their programs, right? So typically what happens is that people take a traditional program like physics or electrical engineering or even chemistry, and they spice a little quantum on it. And that's one method of doing it. But as far as like specific quantum degrees, so there's quantum information that you'll see, there's some quantum computing degrees, and then there's also some quantum engineering degrees. But particularly at HBCUs, to my knowledge, right now, there's nobody that has a concentration in quantum right now. However, one of the major pushes in year 3 of the IBM HBCU Quantum Center, and then also this consortium that I work with, which is the REACT QISC, is to help HBCUs and other MSIs and other places in general develop these programs in quantum engineering, whether it's a brand new degree or something that's close to it with respect to getting the right courses. Probably something very similar to what goes on in the world of data science, even though you guys have a lot of momentum.
Yeah, well, quantum, you do it bit by bit, and there's data that goes in there, and finding new ways to process data and all the rest of that. It's all there. It's all in the same bag, sort of thing. And so somebody asked if you mind sharing your paper on quantum tomography.
Oh yeah, so the majority of our work is free and available on the internet. But I can send it in the chat or I can put it there. But if you read our most recent paper in New Journal of Physics, it's open access. And it's machine learning. It's the last project, the machine learning informed prior for Bayesian statistics. It's one of my favorite works. And then also the other one that might not be free on the internet is the one that made the cover that was in collaboration with the IBM HBCU Quantum Center. I can be more than happy to send that out to you all because it's one of my favorite papers, I'll say.
Fantastic. You got to have those. I love that. And somebody asked about your institution, University of Illinois, Chicago, if it's an HSI. And it's been an HSI for a hot second, since at least 2015-ish.
Mm-hmm. Yeah, and it's one of the interesting things about so I worked in the HBCU space for the majority of my career, and I was blessed to do that. But one of the things that I'm learning more about is kind of Hispanic serving institutions, and in particular, kind of the fact that as far as Research One Hispanic serving institutions, that UIC is the only one in the Midwest. A lot of them are in California and or Texas for various reasons. So that being in quantum, we actually serve an important role with respect to encouraging the Black and Brown community of Chicago to be involved in quantum engineering and quantum computing. So myself and another Morehouse colleague of mine, Dr. Chase, who's the second Black electrical engineering professor in the department, I was number one. We worked really, really hard with respect to getting Hispanic serving institution status, but also having Black and Brown students involved in everything that we do.
That's right. Because when I was at NSF, where I started up the HSI program there, we actually did a visit to University of Illinois Chicago to figure out how we should do it. So yeah, it's a great institution. I really enjoyed my visit there. And really, it also, when I was at NSF, I also worked in the Convergence Accelerator over the quantum track. That was my last gig. So the project at Ohio State and I put that in the chat, the Q's team. That was super, just super what they're doing. Super.
Oh yeah. And they'll be at NSBE. So for those that are interested in QSTEAM, they'll be doing some activities for any of the AUC students that are interested in learning more about quantum. So that'll be on day 2 of our program. So please reach out to us. And then shout out to my graduate student, Dr. Future Dr. Blackwell. She's in the chat.
Okay, fantastic. Awesome. I love it. I love it. And then, okay, everybody's 1-year paper. Yeah. So I'm just reading the comments in there, and I really echo all the comments where this was super informative. I got so enthralled by what you were saying. I love quantum. And really, this is a great presentation, Dr. Searles. Really appreciate you taking the time. If there's any way we in the AUC or our broader communities here can help support your work and really spread the quantum love, so to speak, and reach, just let us know. And thanks for dropping the links in the chat there so you all can grab those and enjoy the papers over the weekend, also as we read all of the different acts and things coming down on legislation. But really super informative. There's a lot of work that needs to be done. People are looking to make investments in this space. And so really thank you, Dr. Searles, for sharing with us and inspiring us to think big and beyond and shooting over. Is that the planet Earth behind you? Is that?
Yeah, something like that. And I just want to just state again that I'm here as just Thomas as the quantum nerd, but I also am representing IBM HBCU Quantum Center with respect to this community. So if you do want to be engaged, if you need a scholarship, if you want to be engaged as a graduate student in quantum research, and it may not be available at your institution, please reach out to my email address. We're more than happy to facilitate working with me and or one of our research advisory board members or any of the above. And then especially faculty, if you're interested in kind of figuring out how you can get involved, whether that's through research projects and or funding and or building programs, that's something that we would love to do. And there's a lot of intersection between data science and quantum information, and it'll only grow. So we can hopefully grow together.
Yeah, that's what I'm looking forward to. Great. It's super great. Well, thank you. You definitely made my Friday shine bright. So thanks everybody for joining us today. We'll see everybody in a couple of weeks here to celebrate Du Bois's birthday via the W.B. Du Bois Data Science Symposium, where we're going to have, we're going to do autonomous vehicles from North Carolina A&T and equity policy with artificial intelligence with a researcher from Morgan State, or should I say the great Morgan State. So please come join us in a couple of weeks. You might have a different platform to log on to. It's the registration, it's free, it's open to the public. And if you can't find it, it's on our website, and I'll see if I can do 2 things at once and put that in the chat just in case you want to register. But with that, I hope everybody has a great rest of the day and a great weekend. And thank you, Dr. Searles. Don't be a stranger in the data land. We love quantum.
No doubt. Thanks to everybody. And then I'm looking forward to talking with everyone soon.
Thanks so much. Have a great rest of your day.